Hola, chaps. Mr. Turek here. In this episode 2, I'm going to go over the syllabi for the 3 different courses I'm teaching. Here's the agenda of what I want to cover in this episode. First, talking about the work you should be doing at home. Secondly, about integrated science, and then the specifics about the 3 different courses I'm actually teaching. So, work at home. You shouldn't be sleeping until noon. You should be getting up pretty early because there's a lot you should be contributing to help your home be successful. So, for starters, right now, just to talk about schoolwork, for both CP chemistry and CP physics, I do plan to use CK12 as the primary means of assigning homework assignments and having those assignments followed up with quizzes to assess how well you understand the content of each one of those little assigned modules. In my aerospace engineering course, probably still working mostly through Google Classroom, but I do feel inclined to establish a CK12 classroom for them as well, so that I can have you practice on your math skills and maybe some basic physics skills, which are not part of Project Lead the Way, but things you should know to be in that course. All right, so at home, you should be developing a routine of not only working on schoolwork, but helping your home be safe and a productive environment. So there are many, many things that go into maintaining a home, and you should be learning about them and practicing some good skills. You should be maintaining your room in good, clean order. You should be checking the health of your family members, maybe documenting them. My wife Linda and I put together a video clip showing how you could follow up on John McGann's advice that says, look, you should take some bleach, mix it with some water, and use that as a disinfectant in a spray bottle. So we put together a brief video clip showing us doing that here at our home. Here it is.
In his email of advice, John McGann recommended that we get a spray bottle with some bleach disinfectant in it. Linda has found this small spray bottle, and we found this bottle of bleach. Now, the bottle that we found doesn't have very much in it. I'm going to point my finger and estimate it's probably maybe only this much bleach that's in the bottle. But wouldn't it be fun to measure the density of the bleach? What would it take to do that? Of course, you said, well, we would have to measure the mass and the volume of a given quantity of this liquid, just like we did in the fall semester. So to measure the volume, we could try using the graduated cylinder, and that would be ideal. So I brought one from school, and to measure the mass, I have an electronic balance from our kitchen, which is where we are. So we turn it on, we set it to measure grams. Next step, of course, is to put the empty graduated cylinder onto the electronic balance. And you can see that it's reading 3.0 grams. And let's go ahead and tare it. Whoops, not switch units. That's cheating. So we have to hold it down, and now it's tared. So that means it's reset to 0 even with the graduated cylinder sitting on it. The next step is to take some of the bleach and pour it into the graduated cylinder.
I could do that.
Yeah. I don't want to go above the mark that it can read. So 2 measurements. Number 1, it's recording it as being 45 grams. Secondly, trying to measure the meniscus of it. Very hard to see on this. I could try zooming in. Maybe you can measure it better than I can. But I'm going to call that, this is 40,
Right there.
I will call that 44.5. So bleach doesn't have the same curvature that water does. It's much flatter.
It's 45.
So as Linda points out, we're going to go with a measurement of 45 milliliters for the bleach. So now you have enough information that you can calculate the density of the bleach. we're going to go ahead and now find out just how much bleach we have to work with. Alright, I paused and done some calculations. You will need a calculator as well. So if we were at school, I would have you put away your illegal electronic device and I'd give you some conversion tables to work through, and then you'd have to do a conversion table that says, starting with this quantity, how do you convert it to that quantity, to that one, to that one. However, you're at home right now, and your family's survival may depend on you getting the math done correctly. So I would suggest you go and consult with Lord Google and bring up a cooking measurements conversion web page as an example so that we can deal with the information we have and figure out what to do next. So John McGann recommended that we take 4 teaspoons of unexpired bleach and combine that with 1 quart of water to come up with the disinfectant to use. So here's a web page where I can take the information we have. We have 225 milliliters of bleach in the beaker, plus another 45 milliliters of bleach in the graduated cylinder. When you add those together, how much bleach do we have total? I could pause, but I'm just going to get to the punchline now. You can pause, calculate it, and I got 270 milliliters. Now you know I make mistakes every day, and if I make one, man, I hope you let me know before we're all dead. Okay, so I would start by converting the teaspoons into other useful stuff. So I'm going to just type in 4 teaspoons and ask it to convert it, and look, that's 1 1/3 tablespoons. That is 19.7 milliliters. So I kind of prefer working in the metric units of milliliters. So let's take it from there and start off that we need 19.7 milliliters is equivalent to 4 teaspoons of bleach. Now, how much is 1 quart? So now I'm going to click on quart and type in a value of 1 quart, and it converts that to everything else. I see 1 quart is equivalent to 192 teaspoons. It's equivalent to 946 milliliters, or 0.946 liters. You now have enough information to calculate the ratio of bleach to water. I recommend you do it in units of milliliters, which would be simplest. What is the ratio of bleach to water? In any units, it's going to be the same ratio. So for every ounce of bleach, how many ounces of water would I need? For every teaspoon of bleach, how many teaspoons of water? For every milliliter of bleach, how many milliliters of water? It's going to be the same ratio no matter what units you choose to work in. What do you get? Here's a little bit of an intermission. You might have a different size container at home, so I should have shown you that the size of the container that we're working with in this case says it's 3.78 quarts or 3.57 liters. And yes, we're working in fluid ounces, which is slightly different from ounces. The result I get is a ratio of 1 to 48. So for every teaspoon of bleach, we need 48 teaspoons of water. For every 1 ounce of bleach, we need 48 ounces of water. If I wanted to use up all the bleach, how much water should I add to it? I'm starting with 270 milliliters of bleach. There was extra bleach in the container, but we've diverted that excess to our clothes washer to disinfect white clothes. So that's something you can do as well. Beep, beep, beep. My calculation result is we would need 12.96 liters of water to completely dilute this much bleach. 9.6 liters of water. Well, that brings up an obvious problem. The container cannot hold 9.6 liters of water. it can hold a maximum of 3.78 quarts, or 3.57 liters of water. So think of this almost like a stoichiometry problem, where I have a limiting reactant and I have an excess reactant. In this case, taking on the role of the limiting reactant is the size of the container that we're going to use for our disinfectant bleach. It can only hold 3.57 liters. The ratio of water to bleach is 1 to 48, and you need to think about how much bleach should we really use in this situation. Calculate, please. Hopefully I figured it out correctly, and hopefully you will figure it out correctly for your own home. According to my calculations, given that we can only hold 3.57 liters of fluid in our container, I calculate we can only use 74 milliliters of the bleach that we have on hand. So most of this bleach can't be used. There's 45 milliliters in the graduated cylinder, and then on top of that, if we add about 30 more milliliters total, that's what would go into this container, fill it the rest of the way with water, and there we have a supply of disinfectant to last us for a while. You now need to do this with your own materials at home. Good luck.
All right, next. Integrated science is the term used to talk about a science course that doesn't deal only with chemistry or only with physics or only astronomy or only engineering, but views them as related disciplines that cross over with each other. And what I'm doing is I'm trying to create content, instructional videos for all three of my courses and uploading them to this one YouTube website. If you are an aerospace engineering student, of course, you should have taken chemistry, you should have taken or be taking physics. So you should be watching all the videos that I upload. If you're in physics, of course, you've taken chemistry and you should be watching all the chemistry content I upload, as well as the physics content. But if you're in chemistry and you're thinking, well, the physics doesn't apply to me, the engineering doesn't apply to me, then consider this. This is your chance to see the instructional videos for the courses above the one that you're in this year. That's true for the physics students as well. You could see what's in the aerospace engineering course. And some of it's going to be pretty complex, but I do have to explain it to students who are learning this material for the first time. So you are strongly encouraged, you're invited to check out all the videos that I'm uploading. Not only do I want to put up instructional content, but I also want to put up uh, stuff that's more social, more personal. After all, you're in my home right now. I could, give you a tour of the stuff that's in my office. I can give you a tour of uh, different aspects of my life. So those are there too. And I do have in mind doing stuff like that because we're here for the long term now. The specifics for the chemistry course is the units that we're in right now are stoichiometry, and the units that we're going to be finishing up this semester is thermodynamics. So stoichiometry, you already understand, is going to be dealing with writing a chemical equation, then balancing it, then figuring out how much of this quantity it takes to combine with that quantity to create a result. Thermodynamics is the study of how the flow of heat causes changes of state in substances, how it transforms from a solid to a gas, going to a liquid, how much heat energy is absorbed or released in the process of doing it, what happens when you have two different substances at two different temperatures and you try to combine them. In physics, we were doing waves right when the shutdown started. We're going to continue doing waves. I actually enjoy a lot of the content. It deals with light, sound, earthquakes, GPS constellations, and I will try to have you make some kind of musical instrument at home using rubber bands or a comb or bottles. There are different ways you can do this. We'll study static electricity. We'll probably use something like a PhET sim to have you practice building simple DC circuits, simulated online. A little bit about magnetism, and per student request, and you know who you are, we're going to review thermodynamics. So all those modules for chemistry that I plan to upload for thermodynamics are directly applicable to what I want you CP physics students to be doing as well. In aerospace engineering, I've listed all these little tiny milestones of what we ought to be accomplishing this semester. So, in broad strokes, it says we should be becoming really good at programming and understanding the structure of how to write a program. In addition to that, there's some math that I don't think you're quite so strong on for doing truss calculations, which is how to analyze whether or not a bridge is going to fall down. Trusses are triangles, and I want to do that. And of course, I love STK. So I have in mind that you acquire the skills of doing 6 different basic orbital mechanics tasks, and there they are listed. In yesterday's Zoom chat with my students in all courses, the question came up, is there any extra credit available? I remind you that the Mars Society has a competition right now, and if you are one of the authors of the 20-page proposal that you submit electronically to the Mars Society, then yes, you will get some extra credit for that. In addition, the aerospace engineering students have the opportunity of earning extra credit by getting STK certification. So it turns out that if you have that software installed, then you could go through the training tutorials. They estimate it's like 4 hours of effort at least. And then they will give you a test to take. You'll have 14 days to complete that test and return it to them. And that will get you level 1 certification if you pass the test. You should aspire to at least considering, at least several of you should consider aspiring to do level 2 master certification in STK. And again, it's training modules, getting much deeper into it, learning about astrogator, and then taking a test that you have 14 days to complete and return. There is a third highest level for certification. I myself have not even done level 1 certification officially, but you're welcome to go for it. So each one of these would be counted as extra credit, each level. Because I'm, sharing this with my aerospace students, I do want to point out to even you 10th graders, chemistry students, you CP physics students, if you have a PC and you wish to try to go for STK certification, which would be challenging for you, but not impossible, then you may download the software, install it. I can guide you on how to get a license for it. That will have to be done through me. Once you have a license, the license will be valid till the end of summer. You can then try to work through these tutorials and go for STK certification yourself. If you manage to get STK certification, then yes, you would get extra credit for that as well. So that's it for this exciting episode. Next, I want to just start getting specific instructional videos created and uploaded, dealing with one topic after another. All right? Hang in there. All for now.